Assalamualaikum to Dr. Arifah. Today we are going to present our project 1, Locality of different programs of COMP, CSP and EAR. My name is Nurshafira binti Muhamad Rizal and our group is leading by Muhammad Syahmi with another group member Lau Yong and Ahmad Danial. So, I will start our presentation with the definition of SMP cache simulator. It is a trace-driven simulator. We use bus basic shared memory for the analysis of cache memory system on symmetric multiprocessor. Locality of different programs has been carried out to study the parameter locality and show that there are different localities between programs. This is also to determine the quality of that program or the program itself. NAT cache memory. Cache memory is a reserved storage space to store temporary file or data so that for every subsequent visit in the future, the request for that data can be served out faster like during loading a website or an application. Other than that, cache memory is very useful in reducing the average time in order to access the data object from main memory. Lastly, cache retrieve or computes data to allow user to reuse the data effectively in the next function. NAT is a miss rate. Miss rate is a cache miss occur when the data does not exist or the entry of the existing cache must be removed to provide space for recently retrieved data. His rate is the percentage of accesses that result in a hit, and on the other side, miss rate is the percentage of accesses that result in a miss. What is that mean by locality grade? Locality grade is the idea of caching the useful data centers around a fundamental property of computer programs. There is two types of locality grade, which is temporal locality and spatial locality. A good locality program has the ability to access the same set of data repeatedly from its cache and hence can run faster than a program with poor locality. Next, I pass to Lau Yong to the next section.
First, we carry out the configuration of multiprocessor, main memory, and cache. Memory organization is set to SMP. Number of processor is set to 1. Snoopy protocol is MESI. Bus application is random. 16 worldwide bits. 16 words by block. 8,192 blocks in main memory. 32 bytes as the block size and 256 kilobytes as main memory size. 122 blocks in cache, 4 kilobyte cache size, fully associative mapping. The replacement policy is LRU and writing strategy is write back. Then we click the OK for each part. Then we open the memory traces, PRG, and we choose CEXP. And then OK. In the evolution, we choose the cache, and in the text format, we choose the head mixes and change the steps by step to complete and execute it. Okay, after it's done, yes to perform the final writebacks. Okay. Then we get the table results of the hit misses rate. Then we choose the cache in graphic format. Same as before, we change the step by step to complete and execute it. Okay, after it's done, yes to perform the final writebacks. Okay. First, we carry out the configuration of multiprocessor, main memory, and cache. The processors in the SMP is set to 1, messy as the cache coherence protocol. Scheme for bus arbitration is random. 16 word wide bits, 16 words by blocks with block size 32 bytes. 8192 blocks in main memory with 256 kilobytes main memory. And there are 128 blocks in cache with cache size 4 kilobytes. The mapping is fully associative and the replacement policy is LRU. This is the multiprocessor, main memory, and cache configuration for our project. And here is the hex misses rate of CESP, COMP, and EAR. Next, we move on to the table results. From the table, we can see that the miss rate of CESP is 0.595%, 8.533% for COMP, and 9.790 for EAR. The changes correspond to the execution. So we can conclude that CESP has the lowest miss rate while EAR has the highest miss rate. Moving on, we have the graph results for CESP, COMP, and EAR. And this graph shows that the difference between the miss rate of CESP, COMP, and EAR.
Okay, we move to the discussion. Firstly, my name is Muhamad Syahmi bin Yaacob, metric number S62602. Okay, we move to the first question. First question is obtain the miss rate using the memory traces CESP, EAR, and COMP. So our answer is miss rate for CESP, EAR, and COMP is 0.595%, 9.790%, and 8.533% respectively. The next question, do all the programs have the same locality grade? Which is the program with the best locality and which have the worst? Do you think the design of memory system that spread the locality of certain kinds of program, which will be the most common in system and can increase the system performance? Why? So our answer is no. Basically, every program has different locality grade based on data collected. CESP is the program with the best locality and EAR is identified as the worst, as CESP has the lowest miss rate while EAR has the highest. Yes, design of memory system clearly exploit locality as it affects the hit and miss rate in cache. For example, hierarchical memory layout help to speed up data access and this give good effects to hit and miss rate in cache. As if miss rate become lower, which also means good locality, so system performance definitely will increase. During the development of the experiment, you can observe graphically how in general the miss rate decreases as the execution of the program goes forward. Why? Explain the reasons. The reason is this is caused by the concept of locality, which is program tend to access same set of data over and over again, especially from cache memory. As the program goes forward, the hit ratio will increase and the miss rate will also decrease. Next reason is CPU will refer to cache memory to find the desired data or instruction and cause hit rate increasing when desired data is found, and this cause miss rate to decrease. Okay, that's all from me.
Based on the result of the study, several points can be pointed to conclude this task. First, it is proven that different programs do have different localities, as the result of the study seems to indicate it perfectly through the results shown. The hit rate and miss rate recorded clearly show different figures in execution of different programs. In this case, CSP, COM, and EAR are compared, and it turns out that CSP has the lowest miss rate out of the three programs, which means it is a program with the best locality compared to COM and EAR being the worst with the highest miss rate between the three programs. Relationship between locality and cache memory. Cache memory, as explained in the introduction, is specially designed to enhance system performance, thus it also manipulates locality. Cache hit happens when CPU refers to cache memory and find the desired data, but if not, it will be known as cache miss. So based on the concept of locality, which is when a program accesses set of data over and over again, especially from cache memory, there is a way to determine whether a locality is good or bad. When the program continues to run, the hit rate, which is the percentage of requested data can be found will increase, which subsequently make the miss rate, which is the percentage of requested data results in a miss, decrease. If the miss rate is low, it will affect the system performance, as the lower the miss rate, the system performance will be better, which means overall, it is a good locality.
Okay, that's all from us. Special thanks to Dr. Arifah for giving us chance to present our works, and feel free to ask us any question. That's all from us. Thank you.